So we're talking about communication matrices today. This is lesson 14.4. So what I've got drawn for us is matrix M. Let's go ahead and label this guy as matrix M. And he represents the communication from, let's say, 4 different ships. Okay, I've got ship A, B, C, and D. And we have created a matrix that lets us know how these communicate, which ship can communicate to another, right? So if I look at each element within this matrix, right? So this 0 here, that's an element within this matrix. This 1, this 1, this 1, right? Any number within this matrix is considered an element. If I look at each one of these numbers, they're going to tell me whether or not a ship is communicating with another, right? And so we're going to look at this side over here as our from, right? We're going to say, so from ship, and then up here we've got the to ship. Okay, so I can look at this and say, so from ship A to ship B, I have communication, right? That's what this 1 means. From A to B, I have communication. From A to C, I have communication. From B to A, I have communication. From B to C, there's no communication, right? There's no connection from B to C. Now, why don't we go ahead and take this matrix and kind of flesh it out and create a diagram that kind of shows exactly maybe a picture of what's going on here, right? So let's create ship A, ship B, ship C, and ship D, right? And we're going to let these guys be represented by points, all right, or vertices that are going to be connected by edges, okay? So I can look at this and I say, well, where does A communicate to? Well, it looks like A communicates to B and C. So I'm going to draw a little line. I'm going to say, well, this goes from A goes to B, and A also goes to C. All right, that's it. It only communicates with B and C. Well, it looks like B communicates to A. And some of you may be thinking, well, I already have a line connecting A and B, so do I need to do anything else? And, well, yeah, you do, actually. You need to say, well, B also communicates back to A. Let's look at C. C communicates with every other ship, right? So C communicates with B, it communicates with A, and it also communicates with D. And then we see that D only communicates with C. So C really seems to be a hub of communication here. You guys will notice this diagonal line across our matrix. It's full of zeros, which makes sense, right? This is saying, hey, A cannot communicate with itself because there's no need for A to send A a message. There's no need for B to send B a message, or C to C, or D to D. Right, so we wouldn't expect to see a line going off and coming back like that, right? It just wouldn't make sense. So this is our communication matrix. You are, for your test, going to need to be able to either go from here to here, or from here to here. You're going to need to be able to write out a communication matrix based on maybe a picture like this one, or write a matrix based, or write a picture based on the matrix itself. Okay, so, well, what if I wanted to look at this and figure out, what if I needed to get, a message from A to D? How many different ways could I go about doing that? Or from C to B that doesn't go directly from C to B? What if ship C is too far away from B to get a message to it? Is there another way that C could relay a message to B? And to find that, what we do is we square we square our matrix. Okay, so we are able to take matrix M and square it. When you square a communication matrix, this gives the indirect two-step paths, right? This gives the indirect two-step paths. That use one ship as a relay, right? So if I wanted to go from C to B, I could say, well, I could go C to A and then A to B, right? That would be a two-step relay. I could go from D to C and then C to B, right? That is a two-step relay. So when we square a matrix, right, really what I get, M squared, is just going to be A, B, C, D here. I'm going to take this matrix and I'm going to actually square it, right? So I've got 0, 1, 1, 0, 1, 0, 0, 0, 1, 1, 0, 1, and 0, 0, 1, 0. If I square that matrix, and we don't have to go through and, show our work for all of that and whatnot. All right, I can just plug that into my calculator and then, take, matrix or determinant, whatever you've set it up as, and square it. All right, and you're going to get something that looks like this. You're going to get 2, 1, 0, 1, 0, 1, 1, 0, 1, 1, 2, 0, and 1, 1, 0, 1. Right? This is the squared matrix. And again, this tells us the indirect two-step paths that use one ship as a relay, right? So if I look at, let's say I'm looking at this value here, this 2. That tells me the number of two-step paths from A to itself. All right, so I could go A to C and then C to A, right? A to C, then C to A. That is a two-step relay. I could go from A to B and then from B to A. If I look at this 1 here, that tells me the number of two-step relays from C to B. Right? I can go from C to A and then A to B. This 1 over here, that tells me that I can go from D to D using one other ship as a relay one time, right? I can go D to C and then C to D. So these two-step relays are going to tell you how many times you can relay something to another ship and then to another, right? And then if I wanted to add, if I wanted to go even further, I could maybe take M and then add it to M squared. This would give me the number of paths that take either one or two steps, right? This takes the number of paths that either take one or two steps. All right, and we can go on and on. If you looked at M cubed, that would give you the number of three-step relays. If you did M plus M squared plus M cubed, that would give you the number of communication paths that take no more than 3 steps. Right? There's so many different ways that we could approach this. So what I'm going to do is I'm going to look at one more problem with you guys, and it's just going to be taking the picture this time and making a matrix from that. So the picture that we've got is it's number 1 on page 540. This is actually one of your homework problems, and you've just got three things that are communicating with each other. Okay, we don't know what they are. It could be, I don't know, a network between computers or something like that, right? So I've got A, I've got B, I've got C. And I know A communicates with B. I know B communicates with A. C communicates with A. And then C also communicates with B. So whenever I'm making this matrix, my first step is to know, the size of this matrix. Since I've only got three points that are being connected, it's going to be a 3 by 3. And remember, we're going to go from and to, from and to. So, what does A connect to, right? Does it connect to anything? Well, we know it doesn't connect to itself, right? So we're going to put zeros in our diagonal. C doesn't connect to C, A doesn't connect to A, B doesn't connect to B. Well, it looks like A only connects to B, and it does that through one pathway, right? A does not connect to C. Okay, well, let's see where we can go from there. B, what does B connect to? B only connects to A. It does not connect to C. And then we can see clearly that C connects to both A and B. This is not the greatest flowing connection chart because, no communication is making its way over to C. It's only sending to A and B. But, maybe this is just how this setup is working. Okay, well, if you guys have any questions, don't hesitate to reach out. You are going to only have something on your test that looks maybe something like this, going either one way or the other. And then you are going to have to find an m squared for your test. So if you guys have questions, don't hesitate to reach out.